The diagram shows the setup of our experiment. It is clearly seen that a piece of newspaper is used and cut into the shape shown. Then, each slot is punched at 4 sides A, B, C and D so that the polypropylene raffia string goes through each slot. Also, slot A and B is parallel to slot C and D respectively, making line AC perpendicular to line BD. String at A and B is tied to their respective hanger on the wall while string C and D is tied to a load with mass 4.25 kg and 1.75 kg respectively. Before the experiment, we need to find out the thickness of a sheet of newspaper. However, one sheet of it is too thin to be measured. Thus, a ruler is used as the diagram shown. We have to determine how many sheets of newspaper needed to make the reading of ruler be 0.1 centimeters. We managed to stack 12 sheets of newspaper to make the thickness of 0.1 centimeters. From the calculation, the thickness of one sheet of newspaper is 8.33 power of -5 meters. Therefore, we found out the normal area is 9.996 power of -6 meters square. In short, sigma x is equal to 1.72 megapascal whereas sigma y equal to 4.17 megapascal. Since there is no shear force involved, tau xi is 0. This is the paper specimen that we used in the experiment. The newspaper is cut into this shape to avoid the stress from concentrating at the grip point and break at the grip point. We use MD Solid software to calculate T to P. The figure shown the result of the calculation. Theoretically, what we get from the SLID software calculation, 2 theta P is equal to 180 degree, thus theta P is equal to 90 degree. The experimental result is similar to the theoretical value that calculated by MD Solid software. Thus, the experimental value of sigma x and sigma y is accepted. This is the result of calculation for absolute maximum shear stress and maximum in-plane shear stress by MD Solid software. For newspaper, the maximum in-plane shear stress is 1.225 megapascal whereas absolute maximum shear stress is 2.005 megapascal.